Hey guys, this is Miss O'Donnell. Today we're going to continue to talk about quadrilaterals. Yesterday we learned about the parallelogram branch of this family tree. So we learned that quadrilateral is any four-sided polygon, and one branch of that are parallelograms that have two pairs of parallel and congruent sides. Then we talked about some special cases of parallelograms. Today we're going to talk about trapezoids and then kites. So let's start with trapezoids. We know that it comes from a quadrilateral, so it has four sides. And we also know that it has one pair of parallel sides. So here's a diagram. We see that these two sides are parallel, and we call them bases. We would call this base 1, base 2. And we see that we have two non-parallel legs. The second thing we need to know about a trapezoid is that its consecutive angles on one leg are supplementary. So let's take a look at what that looks like. We have our two bases that we know are parallel. So here we have parallel lines cut by this leg, which acts as a transversal. So we see that we have consecutive interior angles here. So we know that they are going to be supplementary. Supplementary, again, means this angle plus this angle will add up to 180 degrees. Same thing on this leg. We would have this angle and this angle adding up to 180 degrees. Trapezoids, similar to triangles, trapezoids also have mid-segments. So we talked about the mid-segment theorem as it applies to triangles, and today we're going to talk about a mid-segment of a trapezoid. So in a triangle, we saw that a midsegment was a line segment connecting two midpoints. For a trapezoid, we see the same thing, except we need to make sure that it connects the midpoints of the two legs, so the two non-parallel sides. So we have a midpoint here, which creates these two equal line segments, and we have a midpoint here, creating these two equal line segments. What's special about the mid-segment of a trapezoid is that we can find the length of it using this formula. The length of the mid-segment is equal to 1/2 the sum of the bases. So it looks like this. M is equal to 1/2 B1 plus B2. B1 and B2 just represent the length of this base and the length of this base. Okay? So let's say this base was 10 and this base was 20. If we added those up, that would give us 30. And we took 1/2 of 30, we would get 15. So this mid-segment would be 15 units long. Okay? Let's take a look at some questions that you would see with trapezoids regarding their angles first. Okay. So here's a trapezoid. We see that MJ and LK are the parallel bases, and these are the non-parallel legs. So we have 79, and this angle K we need to find. So they are consecutive angles on one leg, so we know they're supplementary, and we know that they're going to add up to 180. When we subtract 79 from 180, we're left with 101 degrees for angle K. Let's take a look at another example. We see here that we have FG and EH as the bases, the parallel bases, and we see that GH is a leg. We have one angle here, angle G is 90 degrees, and we are missing angle H. Again, we know that these two are going to be supplementary, which means they add up to 180. So this box represents 90 degrees plus x, our unknown, is equal to 180. When we subtract 90 from 180, we're left with 90 degrees for angle H. Let's take a look at our trapezoid mid-segment questions. Okay, so here we have we have side XY and side WZ as the two bases, and AB is our mid-segment that we need to find the length of. So let's recall our formula, which is 1/2 times the sum of the two bases. So 1/2 times 11 plus 17. Do this addition first, and then take 1/2 of that. We will get 14. Let's take a look at another example. Here, again, we are missing the mid-segment, but instead of just leaving it as a question mark, it gives us an equation. So we need to use our formula to set up an equation. So again, we know that this mid-segment, GH, is going to equal 1/2 the sum of the bases. So instead of just setting up M equals, we know that M, the mid-segment, is equal to 3x plus 3. So we're going to plug 3x plus 3 into one side of the equation, and the other side we're going to use our formula, 1/2 23 plus 55. 1/2 78 is equal to 39. And now we just need to solve this two-step equation. So we subtract 3 from both sides and then divide by 3 to get x is equal to 12. And if they asked you to plug back in to find the actual mid-segment, you would just take this x and plug it in here. Substitute it in. So all these properties of trapezoids apply to another polygon called an isosceles trapezoid. We've seen this word before, isosceles. We've seen it when we're talking about isosceles triangles. Isosceles triangles, recall, have two congruent sides. So in this case, for a trapezoid, it will have all the properties of a regular trapezoid that we just talked about, and the unique properties will be that the two legs are congruent and that the two base angles are congruent on each base. So let's take a look at where our legs are. Our legs are the two non-parallel sides, here and here. So we see that they both have 3 tick marks in pink, meaning that they are congruent. And here's our first base, base 1 up here. And we see that the angles on it, the two green angles, these are congruent. And our second base down here, our 2 blue angles, are also congruent. The diagonals, the purple diagonals that you've seen drawn for an isosceles trapezoid will be congruent. They will bisect each other. They will create 2 congruent triangles, 1 and 2, and they will create 2 similar triangles, 3 and 4. Let's take a look at an example. So here we have an angle example. We have angle S is equal to 51 and angle Q is equal to 28x minus 11. So since angle R and angle Q are congruent, this angle and this angle are congruent, we can say that angle R is also 28x minus 11. Also, from the properties of a trapezoid, we know that angle R and angle S are supplementary, or that they add up to 180 degrees. So we can add these two things up to 180 degrees and solve. So we'll get 28x plus 40 is equal to 180. Subtract 40 from both sides, divide by 28, you should get x is equal to 5. Take a look at one more. So it says, if Km is equal to 22, find JL. Since the diagonals are congruent, how do we know the diagonals are congruent? Because we have an isosceles trapezoid. We know it's isosceles because JK is given 2 tick marks and LM is given 2 tick marks. So that means that these 2 legs are congruent, making it isosceles trapezoid. So since this diagonal is 22, this diagonal will also be 22. So JL will also be 22. And finally, we have kites. So a kite has two pairs of consecutive congruent sides. So let's take a look at what that means. So consecutive means right next to each other, right? So we see this side with two blue tick marks will be congruent to this side right next to it with two blue tick marks. And this side with one green tick mark will be congruent to this side with one green tick mark. Oh, whoops. We know that the opposite angles in between the non-congruent sides will be congruent. So all that means is these two pink angles across from each other are congruent. We don't know that these two angles are congruent though. So be careful. Make sure the angle is in between the two non-congruent sides. And then the diagonals, if we were to draw the diagonals like down here, we see that they are perpendicular to each other. And remember, whenever we see this 90-degree angle and we create these four right triangles, we know that in some problems we might need to use the Pythagorean theorem to find missing side lengths. Let's take a look at some kite questions that you might see. Quadrilateral TUVW is a kite. What is the measure of angle U? So angle U is right here. Okay, so let's take a look. U is in between a side with two tick marks and a side with one tick mark. So this angle U and angle W are the congruent angles in this kite. So V and T, you can see that these are not congruent. So how are we going to find these two congruent angles? What we should do is we know that we have 1, 2, 3, a four-sided quadrilateral, right? So we know that there's 360 degrees in a quadrilateral. So we can add up 119 degrees plus 87 to give us 206 degrees. So if we have 206 degrees out of 360 total, let's find out how much we have left. So if we do 360 minus 206, we'll get 154 degrees left in this quadrilateral. But we need to split it up equally into two more angles. So we take 154 and we divide it by 2. So we get that angle U and angle W will be 77 degrees each. So angle U is equal to 77 degrees. And you might see some other types of questions for kites with this right angle. But that's it for this presentation. So make sure you go back and pause to take notes whenever necessary. Thanks for listening and have a great day.